try to connect pentagons so that all the edges connect to each other completely. The only way pentagons can connect is in 3 dimensions to make this shape a dodecahedron. There's a variant on the dodecahedron. It's called pyritohedron, and it has one side of each pentagon that's longer than the others. And you see that in pyrite, and you can connect up these different pentagons, each with exactly the same shape, but one side longer than the other. Now here's pyrite that comes naturally in this particular shape, the pyritohedron. Like the dodecahedron, it has 12 sides, but it's just stretched out so that one side is longer than the others. Now there's another 12-sided polyhedron, which is called the rhombic dodecahedron, and you connect that up with diamond shapes, and you see that in garnets. Rhombic dodecahedron, anyway, it has 12 sides. Now there's minerals that come in this shape, which is an octahedron, 8 sides, completely symmetrical, so it's a regular polyhedron, and we see that with this fluorite. Fluorite can come in this particular shape, the octahedron. Beautiful mineral that we're going to learn how to look deeply into the colors as well as the shape and draw it. Now the octahedron fits amazingly, perfectly into a cube, so that each vertex or corner of the octahedron touches exactly the middle of one of the faces of the cube. We're going to learn to code this. We're going to learn to model the octahedron and cube in Scratch, and to do that, it really helps to have a real model, so that when we get to more complex shapes, we know what we're doing. For example, the icosahedron, which is made up of triangles, 20 triangles, we're going to make a real model, and we're going to code a model in Scratch. Having real cardboard models or models made out of plastic or transparency helps to see which shapes can connect up in 3D and in 2D, and which shapes can only connect up in 2D. Now the triangle can connect up in 2D to make a tiling on a flat surface like a puzzle, and can connect like this icosahedron in 3D. So we're going to make a little icosahedron, and it turns out that certain viruses, many viruses, have this shape. Here's a little representation of a virus, a icosahedral virus. We give you as a download paper that you can fold. Triangles also connect up in 3D as 4-sided tetrahedra, and also 8-sided. So here's something interesting. Triangles connect in 2D to make flat tiles, or 3D in many different ways. Squares can connect in 2D to make tilings or as cubes, but pentagons can only connect in 3D. They don't tile in 2D. We can connect it up here to make a dodecahedron, but remember, we cannot connect it flat on a table. We're going to celebrate the beauty of this dodecahedron with a little art project celebrating the symmetry of flowers, and it also has a practical use as a soccer ball. It's almost round, so you can puff it out a bit to make a ball. But what about hexagons, 6-sided polyhedra? They connect on a table on a flat surface, but they do not connect up in 3D. At least not with just hexagons. If you add some pentagons, you get a standard soccer ball shape, And we're giving you all these shapes, by the way, so you can download them, cut them out, and fold them. And we show you all the scratch codes so you can model these with code and cardboard.